That same little turtle.
3, 2, 1. Yes.
Good afternoon, NuMinds. It is episode 24. Now listen, today I got something for you that you might be a little bit surprised to hear. And that's that paper airplanes are actually extremely educational. Okay, actually, so listen, if any of you have been tuning in, hearing some of our broadcasters or NuMinds TV inspirators talking about this, we have a super cool event next week for Earth Day. It's the Global Cardboard Challenge. Now, actually, the Cardboard Challenge is something that we've been doing at NuMinds since we started years and years ago. But this year, because of the situation, and we're all, in quarantine, we're doing it a little bit differently. So I want to show you something real quick. And then we're going to do today's activity, okay? So let me show you a site that we have set up for the very special event next week that I'm talking about. It's the Cardboard Challenge. And I mean, I can't even begin to tell you how cool and exciting it's going to be. So this is the NuMinds.tv website if you've ever seen it, but NuMinds.tv/Earth Day 2020. You see that super cool countdown timer? So that is how long until the international global cardboard challenge by NuMinds starts to coincide with Earth Day. So I just want to show you guys this. The way it's going to work is for 24 straight hours, they're going to be projects, events, videos, live streams happening that all have to do with taking used, recycled stuff and turning it into something awesome, making creations, right? Well, what do I mean by creations? Oh my gosh, guys. It could be an arcade game. It could be a city. It could be a new invention. That's what you'll have to tune in and see. Amazing. So I wanted to get that on your radar, and kind of in honor of that, to get you thinking about that. That's why the theme today is paper airplanes, because a lot of us think paper airplanes are less about learning and more about just playing. A lot of times, in the movies or TV shows, when there's a paper airplane in the classroom, someone's about to get in trouble. Have you noticed that? Like, why is it that paper airplane equals in trouble whenever paper airplanes appear in a classroom, in school, right? In the movies or whatever, right? So at NuMinds, we think paper airplanes can be a source of super learning. So what we've done with this event that we do called the Cardboard Challenge is we have a whole section called the Science of Paper, and we take different projects that use just the most basic thing in our 3D world, which is paper. Could be cardboard, could be paper, different variations of paper, and turn them into super cool STEAM learning experiences. So the simple, humble paper airplane, if you will. So this is, a classic paper airplane, right? What would I call the classic? Like, this is the first one that I ever learned how to make. And I'm not gonna use today's session to walk you through step by step how to make it, because my goodness, there are a gazillion YouTube tutorials out there on how to make different types of paper airplanes. But what I am going to do for you, in the link in the comments, you will see that there is a folder, and in there are templates for 3 super cool different types of fancy paper airplanes. Like, if you want to go with the classic, that's fine. But if you want to really stretch and explore and think like an engineer, then there's 3 templates out there. I'm going to show them to you in a second, but I'm just giving you the little preview right now. Check those out. So, okay, what do I mean by, paper airplanes can be an awesome learning experience? Well, thank you for asking. There's actually so many directions we could go. One in the handout, so parents or teachers, if you're watching, in the same folder where you have the templates for more fancy paper airplanes, there's a sample NuMinds guide sheet. I don't like the word worksheet, but guide sheet / worksheet that has two kinds of STEAM-based activities. One has to do with kind of understanding the concept of lift. So guys, one thing, an airplane's an airplane, right? So how does a glider actually work? Has to do with air pressure and lift and drag and things like that. So that's one direction we could go. But today, what I want to do is focus on something maybe even more cool and simple and straightforward. Have you ever wondered this? Like, look, we've all been doing paper airplanes since we were kids, and even adults like to play with them. They just don't always admit it. But when you make your paper airplane, everyone has kind of like their way, their little trick. When you take your paper airplane and you throw it, what are the two things that you're always watching for usually? Like, how far and straight did it go? And how fast did it go? So that's what I want to talk about today, is how you can turn making paper airplanes into a very cool scientific experiment. And even, I know, I don't like to say the M word, but a math activity. But if you have to drop the M word to convince your parents to do it, then do it. That's all I'm saying, okay? Because it is actually really cool math and science. So did you guys know that the formula for calculating how fast something goes is actually pretty easy? Okay, so speed, I'll show you on my clipboard in a second. Speed equals distance divided by time. Okay, so how fast something goes, we need to know two things in order to figure out this side of the equation. How far did it go? And how long did it take to go that far? And if we know those two things, we can calculate how fast it went. So here's what I did. I went out into my backyard and I had a tape measure. Okay, you guys know what a tape measure is? This is the easiest one that I had. So a tape measure is kind of like a flexible ruler where you pull it out and it has the measurements on there. So I had a tape measure. I had some tape, of course, and I had my paper airplane. The only other thing I need for this project or activity actually is a stopwatch. You might have noticed that on the starter screen. But guess what? Guess where you can find stopwatches these days? On any device on Earth. So if you have a phone, mom or dad's phone, there's a stopwatch on there. So you're going to need that to get the time. So here's what we're going to do. And we're going to go outside in a second and I'll show you how I marked it up. And we're going to do a little test throw of the airplane and measure. But here's what we're going to do. We're going to measure. We're going to choose a starting point and we're going to flag it somehow. If you're on a sidewalk, just take a big piece of tape and go straight across, and if you have a marker, that's even better. You can write starting line, okay? Because you want to be consistent when you're taking these measurements. So you want to mark it. And then with your tape measure, you're going to measure out. What I chose to do, I did 18 feet. Because if you do too short, it's not far enough to get a good measurement of your airplane. But if you go 700 feet, personally, I can't make a paper airplane that goes 700 feet. If you can, then you might belong at the Airplane World Championships, if they exist, right? So what I chose was 18 feet. Okay, so I marked out 18 feet, the start and the finish. I got a buddy to actually do the measuring for me. It's really hard. It's really hard to have your phone stopwatch in one hand and your plane in the other, and you're going 3, 2, 1, start. It's possible. You can coordinate and push the start button, and then you watch when it crosses the finish line, and you mark it. And then you're collecting, here's the fancy word, you're collecting data, okay? So the first piece of data we have, I can actually record now. So if we want to calculate the speed of Mr. Ben's classic paper airplane, okay, speed equals distance, all right? No, wrong way. There we go. Okay, so speed equals distance. What's my distance? You guys remember what I told you? 18 feet, okay? 18 feet. Now we're gonna use feet for now, because that's what my tape measure is. But we know that in science and around the world, it's the metric system. But at the end of this, what we're gonna do, because I want to know how many miles per hour my paper airplane goes. So that's what we'll convert it to later. And so what we're missing here is question mark, how many seconds? How many seconds, right? So let's go. You want to go see? Let's follow me outside for a second. We'll do a test run with this. When we get back, we're going to see how fast it went. And then I'm going to show you the templates for these radical, and that means awesome, by the way, awesome other paper airplane templates that you can use. Okay, so I don't need these again because I already measured it out. So I'm just going with my airplane and my stopwatch, which is my phone, okay? So follow me. Hopefully we won't get attacked by my crazy dogs. Have you guys been in a lot of meetings and classes where dogs just appeared in the background or you heard them barking? Yeah, that's regular these days. Okay, so here's what I did. Let me set you down. Make sure you can see. Okay, so on the ground here, you're going to see my starting point, since I'm on a grassy backyard. Hey, there's Ricky, my chihuahua. Right there near Ricky is my starting line. So what I did was I put this stick and I put a little use tape to make it a little flag so it's easy to see. So that's my starting point. And then remember I measured out 18 feet. It's from this starting flag to the pole there. Okay, to the pole there, right behind the bench. So that's what I'm going to measure. And so I had my buddy, with the stopwatch. I go to the starting line. 3, 2, 1, launch. How many seconds does it take to get from here to there? Now, earlier today, I did a test run in the front yard where it was a little too windy. And I failed many, many times. What I mean by fail is my airplane didn't make it to the finish line because it would twist and twirl and spin and get stuck in the tree. But back here, because it's the backyard, the wind's a little calmer, and you may have to experiment too, okay? So let's see if I can get this to go all 18 feet. Just in case, I already have a measurement from earlier that we'll use, okay? 3, 2, 1, launch. That, my friends, was a glorious flight of a classic paper airplane. I don't know how much of it was caught on film, but I'm going to super slow-mo that thing later. That was beautiful. Okay, let's go do math. Let's go do a little math, okay? So, 18 feet, that's our distance, right? And the time measurement that I got earlier was 1.12 seconds. That's how long it took to go 18 feet. So let's go back to our board here and record. This is our data sheet, right? Again, turned around. Okay, so 1.12 seconds. And now I'm going to need a calculator. So I'm on my computer. Don't worry, it won't mess up our conversation here. I'm going to pull up the calculator. Are there any human calculators out there watching now who could just do this? Okay. All right. So Mr. T has chimed in with a cool link, and he found the world record. Remember I was joking earlier about like if you could throw your airplane 700 feet, you belong in the Guinness Book of World Records at the World Championships. Mr. T has found that the record is, wait for it, 226 feet 10 inches. And it was done in a huge plane hangar without wind effect. That makes great sense. Remember when we were in my backyard a second ago, I was talking about the wind being a factor and causing my flight tests to fail several times earlier? Yeah, so inside a giant building where you would have no wind effect, that would be an ideal place to test this. Man, wouldn't that be fun? To have like a whole day in a giant empty hangar and just test out different airplane designs? Okay, sorry. Back to the math. Mr. T got us distracted. So 18 feet divided by 1.12 seconds. 1.12 seconds. And what I get is, okay, here's my number, 16. I keep going the wrong way. 16, not miles per hour though, right? Feet per second. Feet per second. So there is a trick, without getting too deep into the measurement math here, but it's a good thing to do if you have time. But to get from feet per second to miles per hour, there's a little math shortcut you can do, and that's multiply it by 0.68. That's 0.68. So that's what we're going to do. We're going to take 16 feet times 0.68, and that's going to give us our miles per hour. So let's do that. I've still got my calculator up here. Times 0.68 equals, whoa. You know what? That was, I have to say, I'm a little impressed with myself. That paper airplane that I made earlier was going about 10.9 mph, miles per hour. Can you beat that, friends? I think you probably can, right? I think you probably can. I just built the old classic. Can I show you a couple other models that you can find in the folder, in the link? Because I really want people out there, kiddos, to try these different models and let us know like how they did. And I only tried to go 18 feet because I was worried about the velocity, but it could also become a distance contest and you could measure. Okay. So I'm going to share my screen again. And I want to show you some things I have going on. Oh, here it is. Okay. So, all right. So this model is called the Stealth Wing. Okay. So a little qualification here is that these are a little challenging to build. So it takes some concentration. It takes some patience. You've got step-by-step instructions. Okay. And a template. Okay. So you got to print off all the pages. This one's 5 pages long. It's called the Stealth Wing. That's what it looks like when it's done. I wonder how that one would do for distance. To me, just glancing at it, it looks like it might be one to do tricks and spins, which, there's physics projects there as well, Today we're just focused on one thing, which was speed, but man, we could do so much more. So that one's the Stealth Wing. This one's called the Raptor. Oh, wow, this is cool. This one reminds me of like a Star Wars ship of some sort, right? That's called the Raptor. Yeah, there's one more too. This one is called the Condor. Ooh, now to me, this one, because of its shape, I'm just thinking aerodynamic, compact. I have a feeling this one might be fast and straight. So if right now we're going to try one of the fancy ones to test the velocity, see if I could beat my classic, I might go with the Condor first, okay? And just also, this is the main handout and the sample for today. So the first challenge has to do with, we didn't do this one today, but if you want to look at it, can it hold weight? How well does your airplane do holding weight? And so this first challenge goes back to the story of the Wright brothers. You guys remember they were literally brothers who invented the first flying airplane. And there's some cool data here about how far they went and, how their machine had to carry weight. So that's a whole other factor we can talk about. But today we just focused in on kind of number 2, which is finding velocity. And we put this formula in here too, because most of you are probably going to be most comfortable doing feet and seconds. So let's get that converted to miles per hour, because let's just compare it to cars, right? So like, what's the typical speed limit on a highway for cars? Yeah, like 75 miles per hour. It just depends. When I was a kid though, that would have been way fast. When I was a kid, there was a rock song called I Can't Drive 55 because that was considered like the speed limit and super fast. And now 75 is like the norm. Sorry, just walked down memory lane there. So yeah, so how fast, do you remember how fast my classic plane went? I left it out there. 10 miles per hour. So I'm not even close to a car on a highway, but I would be really curious to see, like that would be a fun personal challenge. How close can I get to an actual car? The speed of a car on a highway. That would be fun. Okay, so parents, teachers, a little handout here to guide you. Kids, you've got 3 amazing templates in here that you can try and test. And don't forget, actually, before I go back, let me go one more time. Do not forget about next week, a phenomenal 24-hour cardboard challenge where activities like this are just the tip of the iceberg. There's going to be videos, live streams, lessons, challenges. And by the way, opportunities for you to post and share the things that you're doing and making. And we're going to be able to communicate with kids all over the world. We've got teams of teachers in Asia. We've got teams of teachers in Lebanon. And we got our teachers here in the US. And they're all going to be putting lessons up. And we're going to be seeing action from students in all those places. Amazing stuff. Okay. Brought to you by NuMinds.tv. Tune in next week. It's going to be amazing. So with that, I think I'll sign off for today. My main goal was to prove to you that playing with paper airplanes can be extraordinarily fun and educational. It's like, why do those have to be two separate things, right? So here at NuMinds, we know that they don't have to be separate, that they're one and the same. Like building paper airplanes, experimenting with different cool designs, measuring how fast they go. Like, that's serious learning and it's serious fun at the same time. If you agree, hang around NuMinds.tv because you're going to find all kinds of stuff just like that. Okay? NuMinds TV, thanks for tuning in. Home of real inspired learning. Kids, pursue your passions until they become your talents. All right. We'll see you guys soon. We'll see you tomorrow for the Friday episode of The Vault, and also next week at the Cardboard Challenge online. Okay? All right, guys. Have a great night.